Welcome to the second UAM Feasibility Study webinar for the location at 6200 State Street in Chicago, Illinois. In this second phase, we will be focusing on land use specification, an important aspect of our feasibility study as we aim to explore the potential of urban air mobility in this area. And as you may recall, our first webinar focused on gathering valuable insights from the community through the first phase survey. And we received great responses from the survey, and we used the data to understand the preferences and opinions of the community regarding various aspects of UAM. So in the second phase, we will be presenting the proposed land use specification for the vertiport location, aimed to gather additional data from the second survey and apply these results and other factors that we need to take into consideration for our UAM feasibility study. So as we work towards a comprehensive feasibility study, we pave the way for a sustainable and efficient UAM system in Chicago. So without further ado, let's get started with the second UAM feasibility study webinar. I'm Sandra Formenton, CEO at eVertiKSKY, and I will be joined by Stephen Philpott, our CTO. So today the agenda focuses on the 2023 Chicago UAM study responses and the eVertiKSKY comment on the public input, so the data we received from those surveys, the type and number of aircraft suitable for this location, and vertiport design. So let's get started with the responses from the survey. So as in our previous webinar, the vision phase of this study focuses on different aspects. We have the commercialization, the workforce, the airspace construction, ground space and construction, and also architecture. And all this, it aims to create a hub for cargo and passenger transit, and also create job opportunities for the local community, and also harmonize the airspace with Midway Airport approach and departure, and use the net zero materials and eco-sustainable systems, and of course create an aesthetically unique UAM infrastructure. So let's give a look to the individual element of this phase. So as we see on the slide, we see that this data, based on our research, means that we have an opportunity to create a transportation service that meets the needs of both cargo and passenger customers. And our goal is to create a service that caters to both cargo and passengers, while also providing amenities for customers during their journey. In terms of workforce, so as we move towards the future of transportation, it is important to consider the role of skilled and diverse workforce in designing, developing, and also operating and maintaining the new aircraft infrastructures and systems required for this mode of transportation. So this includes highly skilled pilots, air traffic controllers, maintenance, and also repair technicians, ground crew, and airspace and ground space security personnel, customer service, of course, as well, and support staff. So all these professionals need training and development opportunities to ensure they have the necessary skills and expertise to operate this new mobility environment. So when it comes to airspace construction, so the harmonization of Midway Airport approach and departure with routes defined for local sectors delivery by drone and also intramodal by eVTOLs, and overflight rules within the maximum flight radius of 60 miles is a complex process, but that requires careful planning and execution. But why is this so important? Well, the integration of new air traffic management systems and infrastructure is crucial to the success of our transportation system. So it allows us to efficiently and safely manage the increasing air traffic volume while minimizing the impact on the environment and surrounding communities. So this UAM project is committed to using net zero materials, eco-sustainable systems, and pathways that meld with existing traffic flows and add visual and logistical value to that area. So to minimize the carbon footprint with operation, we are taking proactive steps to understand that the infrastructure is environmentally friendly as possible. So additionally, we are focusing on construction of vertiport and terminal facilities that are crucial to support the operation of UAM aircraft. So additionally, these facilities will be designed to seamlessly integrate with the existing infrastructure and offer amenities that enhance the customer experience. And now lastly, when it comes to architecture, the architecture plan aims to create a unique facility that reflects the value and identity of the community it serves. So it is possible also promote safety and security, passenger experience, aircraft accommodation, or even airspace operation, customer loyalty, and eco-sustainability. Indeed, we'll see that 71% of the community believes that the vertiport should reflect their values and identity, and creating an opportunity to create a facility that meets the needs of urban air mobility and resonates with the people it serves. And this is really important to the community as well. So this slide, so based on the responses, it is clear that the economic development is a top priority for the majority of the respondents. So while environmental sustainability and civic engagement are also highly valued, it is important to consider all of these factors when making decisions about urban air mobility development, as they are all interconnected and can impact the community in various ways. Now, when it comes to this slide, the result of the survey indicates that the benefits of urban air mobility are perceived positively by respondents. The data showed that the UAM has the potential to provide significant benefits to urban areas, particularly in terms of reducing travel time and providing an alternative to mass regional traffic. And additionally, UAM can contribute to reducing costs for passenger and cargo transit, as well as having a positive impact on the environment by reducing the numbers of vehicles on the road. This slide, so the data suggests that the majority of respondents prefer the main artery from the expressway as the entrance to the vertiport location, which could be due to its accessibility and convenience. However, a significant portion of respondents also preferred 63rd Street, indicating that it could be a viable option as well. So overall, the results show a clear preference for the two main roads, while the two side streets are less favored. So here the data suggests that there is a diverse range of opinions among the respondents regarding the number of landing pads for the location. So while a significant percentage of respondents prefer less than 3 landing pads, There is also a notable percentage that envisions 12 landing pads, but the decision regarding the number of the landing pads will likely depend on various factors, such as the available space, the demand for UAM services in the area, and the potential impact on the surrounding environment and community. And this, our CTO, Steve Philpott, he's going to explain this aspect deeper in the further slides. This slide assumes that the respondents are open to different options and not particularly committed to one specific aircraft manufacturer. The fact that the other entries option received the same percentage as Archer Aviation suggests that respondents may be interested in considering alternative aircraft that were not listed in the survey. So here the data indicates that the most popular use case for UAM aircraft among the respondents is air taxi transportation to airport, with 60% of them interested in this option. Well, eVertiKSKY will change your mind about that. But the second most popular use case in air taxi transportation to work, which indicates a potential demand for UAM in daily commuting. And lastly, this slide suggests that the respondents have a strong interest in technical aspects of UAM, so particularly in the design of the vertiport and airspace systems, as well as the regulatory and safety aspects. However, there is also a significant interest in commercialization and economic aspect of UAM, as demonstrated by the interest in joining the commercialization committee. So it is clear that for 6200 State Street, Chicago, Illinois area, the respondents have a generally positive attitude towards urban air mobility, and they recognize the potential benefit that it could bring to the community. And the majority of respondents believe that UAM can improve the value of the area and improve the efficiency of transportation. So additionally, respondents emphasize the importance of safety and emergency response in UAM operation, with a majority indicating that dedicated first response team and maintenance areas for aircraft are essential. So respondents also recognize the potential for UAM to improve logistics and supply chain management in the area. So with a significant portion indicating the importance of eVTOL aircraft, parking and warehouses for cargo storage and forwarding activities. And I believe this is really interesting to see. So while respondents generally prioritize safety and efficiency in UAM operations, they also place importance on aesthetic and visual appeal. So this is evidenced by a significant portion of respondents who believe that UAM infrastructure should include locally produced art and digital billboards. And additionally, a sizable minority expressed a preference for suitable design elements in UAM vertiports, indicating the need for consideration of environmentally friendly options. So finally, it is also encouraging to see that a high percentage of respondents expressed interest in flying a UAM aircraft in the next 2-3 years, suggesting also willingness among residents to adopt this innovative mode of transportation. So overall, these findings provide a valuable insight into the opinions, and that can also inform the future planning and implementation efforts. So when it comes to the survey, this is all for now. I'm going to hand it off to Steve Philpott.
Thank you so much, Sandra. I think it's key to point out that the vision phase, the first phase of our feasibility study as a standard, is probably the most important component, as it fleshes out the data that becomes the catalyst to design around our operational, economic, and infrastructure requirements. We can consider those data points that Sandra covered a moment ago to be our training data, if you will, for how we're going to build this new model of infrastructure for transportation. There's one thing that's pretty clear when you start to look at the location that we've selected for the mock study, is that it's not in, let's say, mainstream, the mainstream public. So it's not downtown Chicago, and it's certainly not on O'Hare Airport. But the 2023 mock UAM feasibility study in Chicago is focusing on the implementation of a vertiport and associated assets as a general approach. In this case, it's an underestimated area in the bustling city of Chicago, but we all know network theory. In order for UAM to work, we're going to need routes. And there's some huge benefits to looking at underestimated areas as places for routes. There's a lot of equity for operators and other stakeholders in doing so. Now, Chicago is unique in that we have long been a hub for transportation and innovation in transportation. So we had the first roads come into the city, the first rails come into the city, and some of the most busy airspace structures connected to the city. So this is an ideal location for the study of urban air mobility because of the type of complexity that we have to concern ourselves with, as well as the implementation requirements that we can develop here and replicate out to the rest of the world. So as we move forward into the application of those data points, I wanted to kind of talk about or give people a lens with which to consider areas that you haven't before. If you're going to build a network or if you're going to fly a network, understand there's huge potential in studying the design and development of UAM for entire cities, not for a characteristic of a location. And one of those is the customization of the location. The ability to go into an area where the land has not been used for quite a long time gives us some economies that allow us to create the baseline vertiport location along with the standard infrastructure, but do some really cool things to make that that system and those assets tailored to the unique needs and challenges of that area. And that can affect the overall safety and efficiency of the system. And those innovations and experimentation can create studies and designs that can be replicated to other areas with similar characteristics and improve their ability to urban plan out those forgotten areas, in fact. While we're in the business of creating vertiport and UAM ecosystems, it's important to note that we will be creating more footprint for the civil aviation industry on the ground than traditional aviation. There will be more vertiports in orders of magnitude than there will be these large airports that exist, and those will accommodate spaces within communities. So to begin to think in this way, it gives us the ability to think about job creation, economic development, sustainable transportation, testing, cost savings, a number of things that will help bring an advancement that was unavailable before while expanding and really accelerating the evolution of UAM. Next slide, please. So while we looked at all of these different elements, the desired services that came from the vision questionnaire, the vision portion of the questionnaire gave us these key desired services. And so we work backward and say, well, based on this gamut of desired services from emergency services to air taxi services, what is it that we need to consider in terms of the area's dimensions? So we have the basic core dimensions of the full-blown area. Working backward, how do we figure out how to fit all this stuff in? So we do that by looking at the land boundaries, the land specification, land use requirements, and we start giving thought to some of the airspace requirements. And these will give us some additional dimensions by which we will begin to design the built environment. Next slide, please. The first thing we do is that we want to make sure that we design once or design several times and build once. Everything that we do is in alignment with the regulatory bodies of the aviation regulation bodies of the countries in which we work. So here in the United States, the FAA has published a vertiport design guideline, Engineering Brief 105, that gives kind of a enhanced, it's a recommendation of vertiports, but it's kind of an enhanced level of what the heliport structural engineering brief recommended. And so based on what we know about the aircraft, the FAA has given some recommendations. There are a lot more regulations that will come down the pike in regard to vertiport development and construction. However, the initial ones that we've taken into consideration are lasting. And those are really, you know, before we start to dig dirt, we have to get a 90-day, there's a 90-day advance notice we have to give the FAA to start the actual work, as well as understanding the coordinated flight paths of the nearby airports. In this case, we're talking Midway, Geary International, and O'Hare, as well as some smaller airports and heliports. And of course, we work directly with the state and local officials to ensure that we are in line with their local regulations. Now, again, we're in not the infancy of urban air mobility, but we're very early on. We're at the point where we're still not sure what's going to go in the ground. So we have to base our next steps, our considerations for the built environment on what we know will stand. So next slide, please. And what we know will stand is based on these guidelines from the FAA that we have already. We know the size and shape of the vertiport is there are minimum dimensions that have already been defined. There are recommendations for the location of the vertiport so that you have a minimum clearance area for approach and departure, as well as integration. And the layout of the vertiport, there's some recommendations on it. I'm sure it's going to change a bit, but for the most part, the safety area and D values, which is the dimension of the aircraft, kind of dictate the true spacing requirement or the layout of the vertiport itself. The lighting at the vertiport, lighting is similar to what you'll see at a traditional airport with a different arrangement, And the signage at the vertiport, the considerations that we have at airports are going to be, considerations at vertiports will be similar to what you see at airports now. However, there will be some considerable leeway in what can be done as long as it doesn't impact the air structures of civil or traditional civil aviation. Next slide, please. Now, we looked at the guidelines for FADOs to kind of determine if we know we've got 200,000 square feet at this location, and the basic guidelines that the FAA provided have these minimum dimensions per aircraft, per landing area, along with its buffer zone or safety area, then we know a minimum FADO size. So we took that 3,960 square foot minimum FADO area requirement and determined what our capabilities would be in terms of the operation, also considering the desired services. So let's go to the next slide, Sandra, and talk a little bit about this, the approach. So in addition to knowing the FADO size, we wanted to know where the customers would be coming in and out of or entering the vertiport area, as well as entering the FADO area. And so the desired services times the number of transactions for that service will dictate the potential number of passengers, right? That's going to give us an idea of how many gates we really want to have for convenience and safety. as well as staffing locations for ticketing, waiting areas, luggage, things like that, parking, and ground transportation for whether it's going to be ride sharing, taxi services, or kiss and ride where the husband drops the wife off to fly to football game in Arlington Heights. Next slide, please. The vertiport airspace integration was the biggest piece that we figured we would pay the most attention to about 3 years ago when we started designing the approach for eVertiKSKY. And so that took into account a number of elements, and we made sure those elements align with the current FAA vertiport engineering brief. But 3 years ago, we wanted to ensure that we had infrastructure, a digital infrastructure that would accommodate that. And we'll talk about that more in phase 4, I believe, which is airspace structure development, design and development. But these are the touch points that we consider in designing the vertiport airspace integration in this particular study. Next slide, please. Based on the sizing, the desired services, and the types of operations that we will likely cover in the study, we believe that we will need to accommodate 12 drones for delivery and safety and other services, and 4 eVTOL aircraft. And we'll talk about that now. So next slide. Okay, so we talked about this area. Our location is, let me see if I can do this. Can I do this? I don't think I can do it. I want to draw. Anyway, our location is down here in the middle, and you'll see it. But these are the benefits of developing routes where routes need to be designed versus considering the area first. This particular area is near a rail line, as we said before, near a mass transit line, and near 2 main streets or arteries into the city. And you'll see here we're about 3.5, 4 miles from the downtown area, just south of downtown, and 8 miles west of Midway Airport, with plenty of approach and departure clearance in their airspace, as well as departure and approach lanes from and to our vertiport location. Next slide, please. So the land boundaries of the area are 61st and State. I don't know how relevant it is to everyone on the call, but the location of State Street is a main vein, and just to the left of State Street is a major expressway. Just on the other side is a major expressway, as well as a rail line. And to the right of that is the Wabash location. And so we're talking roughly a 1/4 mile at this location to play with. Next slide, please. The land specifications are kind of based on what's available to us from those vertices we pointed out a moment ago, and identifying the land specification, which includes a 330-foot by 660-foot area, 3 FADOs, final approach and takeoff areas, a 4th FADO, which will not be for servicing, but for cargo loading, will also be located there. And each of those FADOs will be at the 3,900, the basic reference 3,900 square foot reference aircraft D value. And it's also crucial for us to look at the actual vertiport terminal and airspace structures to be used in the future in this study. So the identification of these specifications provided the information for designing and constructing these assets that we talk about, the vertiports, cargo, and all this other stuff, within these dimensions. Next slide, please. Land use itself, based on what we've been told by the public, we will have a number of different services that will originate from the airport. How big will that service area be? What will be the infrastructure requirement for cargo that's being, for the aircraft that's delivering cargo beyond our 3-mile sector, all the way out to our 20-mile radius versus one that's delivering more frequently within the 3-mile sector. Passenger services, is this going to be something that is redundant? You have more than one service agent for one type of offering, or do you have multiple agents, or do you have spaces for these folks to have lunch? I mean, there are a lot of different things that you work backward from just in knowing these few data points. But these are the data points. These are the services that will be included in the study for this location and provided by the operator. Let's go to land specifications. So the airspace requirements that we looked at were really just to ensure that the integration and designs were just harmonious with the current approach. You hear it all the time. Safety is number one, safety is number one, safety is number one. And it is. But developing a safe and efficient airspace structure is complex. So now that we know the services and we know that we're going to have departures and approaches, we know that we have to develop actual flight corridor structures that provide kind of the standardized flight paths that can provide minimum disruption to UAM operations within that UAM ecosystem, as well as in the traditional airspace, and efficiency. If we can create the corridor structures and provide labels and reporting points, we can increase sequencing and spacing efficiencies through our system. So the airspace requirement has us look at the dimensions of the airport, the height of the airport, the width, the X and Y, and determine out some algorithms that will be used. We'll talk about that more, to manage the airspace within that sector. And the location of the vertiport is the location of the vertiport. The sector is the broader 3-square-mile ecosystem that is managed for efficient UAM operations. Next slide, please. So at the end of the day, what we know from all the data gathered, we still need to do passenger services and a number of other things based on some input from actual operators. We have, we're currently doing one-on-one interviews with consumer packaged good last mile distributors. And we are talking to workforce partners, and we'll be gathering some other information to determine the next components required for our built environment analysis, which will show you the infrastructure for these services which fit in the dimensions that I just showed you. So what we know right now are that the vertiport will have the drone and delivery hub kind of set in stone. We know it's going to be a 20,000 square foot area that's just dedicated to a workforce being able to move cargo either from a intermodal system, such as a box truck that pulls up toward that area, and they pull packages off and put it onto a VTOL to be freight forwarded to another location, or cargo that originates from a drone or eVTOL aircraft and at that location, and then goes to residents or businesses within the sector. And then, of course, you have the other options where the aircraft are coming in, the aircraft being drones and VTOLs are coming into that location with cargo to be offloaded. So we know 20,000 square feet is fair. And with that, we've got enough working area along with loading and offloading area to be safe and secure for the employees and provide security, safety for the cargo itself, which will be a huge commodity for us. And that cargo area will have direct access to all 3 FADOs. And as I mentioned before, that 4th FADO that sits in the cargo area will not be accessible by those other 3 FADOs. So cargo will have access to passenger will not have access to cargo for a number of reasons. But this is the baseline we have so far. This is the baseline we've developed from the vision statement. And so where we had a vacant lot just months ago where no one was thinking about doing anything, We are, I'm guessing 20%, 25% through the design, the ideation of what this location can be as an innovative and contributing a route in urban air mobility in the city of Chicago and between other cities that will have regional air mobility. So at this point, I'd like to give the word back to Sandra to close us out with the additional snapshot of our phase 2 study. Thanks, Sandra.
Thank you, Steve. Thank you for sharing. So right now we're going to focus on the vertiport design layers. So the eVertiKSKY vertiport design layers provide a comprehensive approach to address all aspects of vertiport design elements, which includes the aircraft layer, the infrastructure layer, the environmental layer, the regulatory layer, and the user layer that together create a complete picture for this vertiport design process. So these layers help us to ensure that the vertiport caters to the specific requirements of the aircraft, the infrastructure needed for operations, and minimize environmental impacts. So this approach also keeps us aligned with regulatory requirements and local policies, while of course prioritizing the needs and expectations of our users, including like cargo customers, passengers, pilots, and of course ground support personnel. So let's give a look to each individual layer. So when it comes to the aircraft layer, is essential for creating a vertiport that can handle the unique requirements of UAM aircraft. And that's why we will take into account the selected aircraft by respondents and recommend the best approach. So by selecting the aircraft, we are focusing on the size, weight, propulsion system, and performance capabilities. We can ensure a safe and efficient vertiport environment. So considering the placement and orientation of touchdown and liftoff area and the final approach and takeoff areas, and understanding the characteristics of the UAM aircraft, this will help us to achieve our harmonious airspace integration and efficient ground operation. So the design of ground support assets includes, of course, charging infrastructure, ground support equipment, and safety equipment. So these components are going to help us to minimize the risk of accidents and create a safe environment for all users. When it comes to the infrastructure layer, is indeed a vital aspect for vertiport design, and it provides the foundation for safe and efficient operations by incorporating physical components and systems that support both the aircraft and passengers. So a well-designed touchdown and liftoff area and final approach and takeoff areas and safety areas are crucial for ensuring the aircraft can take off, land, and maneuver without any issues. So these areas must be constructed to withstand the weight and impact of the aircraft. So additionally, navigational aids and lighting systems are also essential components for safe operation, especially during like low light conditions. And these systems not only guide aircraft operators, but also help prevent accidents and maintain a secure environment. So adequate charging and power sources are another important consideration. So a vertiport must have the adequate and necessary infrastructure to support the operation of the aircraft, ground support equipment, and electric charging stations. So when it comes to the environment layer, so we must minimize the environmental impact. So key considerations include the noise pollution reduction through noise barriers and quieter engines, of course, eVTOLs, and site eco-sustainability with environmentally friendly materials and energy efficient lighting, and considering bird migratory patterns and ecosystems. So as we all might know, Chicago is a huge migratory path for these birds. So we really need to take into account this aspect as well. And by implementing green spaces and engaging with the community, we can create a balance between the vertiport and its surrounding environment. In terms of the regulatory layer, so it is a critical aspect of vertiport design, involving compliance with various legal and regulatory requirements to ensure safe and efficient operation, while, of course, addressing community concerns like Steve mentioned earlier. We must work closely with regulatory bodies like the FAA and adhere to their regulations, and including airspace integration, pilot certification, maintenance, and safety protocols. So local land use policy and zoning requirements and also permitting processes are important consideration for compliance with local regulations and also community standards. So this also includes, of course, again, environmental regulations, as we mentioned earlier, such as noise and emission standards to minimize our vertiport's impact on the environment. So it's like, in other words, compliance with regulatory requirements is vital for the success of a vertiport. So it is important to maintain a positive relationship with the community and stakeholders involved. And lastly, we have the user layers, crucial for ensuring a positive experience for all vertiport users, including passengers, pilots, ground support personnel, and cargo customer in the location. So understanding the needs and expectations of each user group is key to designing a vertiport that is convenient, comfortable, and also safe. So for example, when it comes to passengers, amenities like waiting areas, restrooms, food and beverage services, and Wi-Fi connectivity should be provided, to include also an efficient and safe boarding and disembarking process with clear signage and guidance is essential. And when it comes to pilots and ground support personnel, designated areas for briefing or debriefing, secure storage for personnel items, and rest areas should be included as well. And lastly, for cargo customers, the user layer should address safe and efficient handling of cargo with appropriate equipment and facilities. So for today, so this is all for now. Thanks for being here with us today, and please take a moment to complete the land use specification survey using the link provided, and consider also joining our UAM Feasibility Study group on LinkedIn. We appreciate your participation and hope to see you at our upcoming webinar for the phase 3, which is the built environment phase of the eVertiKSKY UAM Feasibility Study. Thank you, everyone.